What's going to be different today that we didn't do on Wednesday is we will not start with a common denominator anymore. We will not have a common denominator to start, and that's when your problems end up looking something like this. So we're going to have to first find our common denominator, and let's talk about that. So this part can be a little confusing at first, but once you see a few of them, it starts to make a little bit more sense. So finding a common denominator is not the same as finding a greatest common factor. It's actually quite the opposite. So make sure you're not getting those two confused. This is 7.4. So we need to learn how to find a common denominator when we have these polynomials, these rationals. The first thing you need for your denominators, factors. You have to factor your denominators to find your LCD. Your lowest common denominator. Then we're going to look at each denominator for unique factors and see which factor it has the most. So this idea is the opposite of a GCF. The GCF, we were always looking for the least. For the common denominator, we're always looking for the most. And we're going to treat numerical factors like any other common denominator problem, and the collection of our unique factors is our lowest common denominator. So the first thing we're going to do is just identify common denominators, and then we're going to apply them to problems. So here's my first set of fractions. I just want to find the lowest common denominator. So when you're finding the lowest common denominator, you don't ever have to worry about the numerators. So I have 4x cubed and 6x. So you've got to remember, this is not the same as finding a GCF. What we're looking for is to start out some number that this number I can divide by 4 evenly, and I can divide this number by 6 evenly. So what number can I divide by 4 and by 6? Think back to basic math, finding an LCD here. I'm not looking for a GCF. LCD. I need this number, think back to, like if I gave you a basic math problem, 1/4 plus 1/6, what's your lowest common denominator? 12. The lowest common denominator, again, we're not thinking common factors. The lowest common denominator for 4 and 6 is 12. It's the number that 4 and 6 will divide into. So think back to 1/4 plus 1/6. Think back to, we had an example last time. Think back to this problem where you had 2/3 and 1/6. So you guys all got me to 6 like that. So we're thinking common denominators now, not common factors. So the number that both 4 and 6 will divide into is 12. Now when you're building an LCD, we're always looking for the most. So I have x cubed in one denominator, x in the other. How many x's in the first one? X cubed represents how many x's? 3. How many x's in the second one? 1. Which of those is bigger? 3. That's how many you need in your common denominator. That's what we're playing with common denominators, is which has more. It's not collecting them all. It's not finding the fewest. It's which has more. Always looking for the most. So my LCD is 12 x cubed. Reason being, I can multiply 4x cubed by something to get up to 12x cubed. I'd multiply it by 3. I could multiply 6x by something to get it up to 12x cubed. I'd multiply it by 2x squared. So when we're thinking of common denominators, we're building our fractions up to them, unlike a greatest common factor where we're taking stuff out. It's the opposite idea there. So in B, my two denominators, I have an x and I have an x squared. Any ideas to what my common denominator would be? Dennis? Yeah. Sure. That both of them can go into. Yes. You want these numbers to go into our LCD, as opposed to a GCF is going into our numbers. It's the other way around. Because that's 12 is the smallest number that I could do 4x times something to give me 12x cubed, and 6x times something there's nothing smaller than 12 that I could bring them both up to, because they have to match if I'm going to add or subtract. So 12 is the smallest number I can do that with. Now other things will work, like 24 works, but it's not the lowest common. So in B, my denominators are x and then x squared. So what do you think my LCD is? X squared. Always looking for the most. So if I look at my first denominator, I have x. Got 1. My second denominator, I have x's. There are 2. The one that has more is the one that goes in my LCD. Because what could I multiply x by to get it up to x squared? Another x. That's what we're going to be doing. We're going to be bumping these fractions up so they have a common denominator. Now C, we start to get into binomials. And when you have binomials, you always want to see if you can factor them. If you can't factor them, you've got to treat them as factors. Treat binomials as factors. So when we build our LCD, we want a collection of our unique factors. So my first unique factor is x minus 7. Next thing is, how many times do I see it in a single fraction? Well, I only have it once in the problem, x minus 7. So that means in my LCD, I need this factor once. I've got to account for that denominator in the first fraction. Now, my other unique factor is the x plus 1. Again, I only see it once in a fraction, so I need it once in my LCD. And that's how you write them. You write them right next to each other as if they were a FOIL problem. You don't FOIL them out, but you don't put, like, sometimes I see people putting a comma between them or the word or. You just, this times, you just line them up as multiplication. So my LCD is going to have both of those factors. And what we're going to do in a minute when we actually add or subtract is you're just going to look at your fraction and see which factor it's missing. So if I want this problem to have my LCD, I'd have to multiply this first fraction here by its missing factor. This second fraction by its missing factor, and that would get them to a common denominator. So we're trying to collect up factors here so that we could get every fraction to the same denominator. Now D, one denominator is y, and one denominator is y plus 6. And the reason I put this one in here is people say, well, I'm just going to use y plus 6 because that takes care of my y. But it doesn't. So y by itself has to be treated as a factor. A monomial y is different than a y that's part of y plus 6. So y plus 6, like we talked about with factoring, is a package deal. You've got to have a whole y plus 6 to match it. Anything different is not a match. So a y all by itself, different than a y plus 6. So there's actually two different factors here. And when I go to build my common denominator, my first factor that I need is y. The second factor I need, y plus 6. I've got to account for the factors from each of those denominators. So it's just as if that first denominator was a y plus 1. It's totally different than a y plus 6 when it's a monomial. All right, E. We've got two denominators here. This is the first time we've seen a factor appear more than once. So the question always becomes, how many times do I need to include the factor in my common denominator? So if I look at my two denominators, I'm going to completely ignore the numerators. So the second denominator is the factor x minus 9. Can't be factored any further, so it goes as a binomial. So my first factor is x minus 9. How many times do you think I need that x minus 9 in my LCD? Once or twice? Got some votes for 2. Once. Once maybe. The answer is once. So remember, we're looking on a fraction by fraction basis. So how many times do I see x minus 9 in my first fraction? In my first fraction, once. How many times do I see x minus 9 in my second fraction? Once. Which one of those is bigger? Well, they're the same this time, so 1. You don't ever add those together. You just pick which is bigger, or if they're equal, that's how many you take. So I only need the x minus 9 one time. Do I need anything else in this LCD? The x plus 9, my other unique factor. So if we were actually working with this problem, we wouldn't have to multiply this first fraction by anything because it already has the LCD, which we saw that with our numbers. If our LCD was 6, we had the fraction 1/6, we just left it alone. The only fraction we'd have to multiply would be this one right here. We'd have to get an x plus 9 into it so that it had a common denominator with the first fraction. Now we look at f. You might say, oh, I got to start collecting x's, I got to start collecting variables, got to start collecting constants. When you build an LCD, you need factors. So if you have a problem where your denominator is not factored, your job is to start by factoring it. So I want to factor x squared minus 1. How am I going to factor that? X plus 1, x minus 1. That's our difference in two perfect squares. You actually had this one on your classwork. And as soon as you have it factored, that's what we're going to use for the rest of the problem. How about x squared plus 3x plus 2? I need a pair that multiplies to AC, which is 2, adds to b, which is 3, and I can use my shortcut here. 2 and 1. So I'm looking at x plus 2, x plus 1, and for the rest of the problem, I'm going to worry about the factors, not the original polynomial. So now we have to build our LCD. So I usually just go down my list. So my first factor is x plus 1. How many times do I have to include x plus 1? Once. In the first fraction, it's there once. In the second fraction, it's there once. We're going on a per fraction basis. They're the same, so we only need it once. That will cover both fractions that have the factor only once. What else should I include in my common denominator? X minus 1, my x unique factor. I see it at most in a single fraction once, so I include it here once. And anything else? X plus 2. I have one more unique factor. And again, when it appears in your problem once, you can guarantee you'll only need it in your LCD once. So the only time we have to really think is when we see that factor in our problem more than once. And then it's, how many times do I have it in this fraction? How many times do I have it in this fraction? Questions so far? Ayana? Yeah, you could have more than 3 if you need. You're good. We won't. We won't. You'll have at most 3. But even 3 is not going to be hard because if I look at this first fraction, what's the only factor that it's missing from my LCD? Yeah, the x plus 2. So it's only missing one factor. If I look at this fraction, which factor is its denominator missing from my LCD? X minus 1. So you're still only multiplying by one factor. Yeah. Where it would get hard is if like this was just 7 over x plus 2, and you'd have to multiply. We're not going to do that. We're only going to ever be missing one factor. And G. Got my 2 denominators. Don't care about the numerators when I'm finding my LCD. When I actually do my problems, we'll need to keep those numerators. But for finding my LCD, I'm looking for factors, a collection of factors. So x squared plus 12x plus 36, can I factor that? What does it factor to? X plus 6, x plus 6. And I would not write that as x plus 6 squared, just because when we get to the actual problems, you're going to want it written out as opposed to having this squared. So yes, it is x plus 6 quantity squared, but I would write out the individual factors here. How about x squared minus 36? X plus 6, yep, 1 plus 1 minus, difference of 2 perfect squares. So now we've got to go to our LCD and decide how many times I need each factor. So my first factor is x plus 6. How many times do you think I need to include that x plus 6 here? I have once, I have twice. Can I get anybody up to 3? No. All right, so a question. How many times do you see x plus 6 in the first fraction? How many times do you see in the second fraction? Which of those is bigger? You got to have it twice. We're trying to cover the fraction that has it the most. When we're building LCDs, we always need to cover the fraction who has that factor the most. So to cover the first fraction, I need to include it twice. There's no way to get rid of these factors in your denominator. So if I include that only once, I'm going to be in trouble because I can't get rid of one of these x plus 6's. The only thing I can do is put another x plus 6 in the second fraction. So we're always building up. And what else do I need in my LCD? The x minus 6. So if you think about it, to think, why is that my LCD? Well, if I look at this first fraction, what factor is missing from its denominator that's in my LCD? X minus 6. So I could easily multiply by x minus 6 over x minus 6. It gets my common denominator. If I look at this second fraction, what factor is it missing? X. Which sorry, I couldn't hear. Another x plus 6. So we need another x plus 6. So see, I could get another x plus 6 into this fraction. I could not take away one from here. That's why we're always covering the fraction that has the most of a single factor. Questions? Can't really tell if you're totally lost, bored. We'll see this in every problem. We're going to need to do this at the start of every problem. So we certainly, if you're still a little on the fence and we're doing a problem, ask the questions now as we're doing these problems. So we're going to add or subtract as indicated, simplify if possible. I made this little checklist here because next time when we solve rational equations, they look very similar, but they have a little bit different process. So the first thing we need to do is find our LCD. It's just like with numbers. Find your LCD, multiply by a form of 1. So last time you told me all to multiply by 2, and I disagreed. I said you had to do 2 over 2. You need a form of 1. Then it's going to look like the problems that we've been working with, where we can just work through simplifying the numerators to get our answer. So the new step today is, first thing we need to do is identify our lowest common denominator. So my denominators here are 6x and 8x squared. So start when it's monomials. This is for monomials. Start with the numbers. Pretend you're back in basic math, and you're adding something with a denominator of 6 and a denominator of 8. Chris? 24. 24 is the smallest number I can divide by both 6 and 8. So we need 24 to cover the numbers. And then how about x's? How many x's, or x to what power am I going to need? X squared. Seeing which one has the most. It's the opposite of a GCF, where we take the fewest. So what we're going to do now, I'm going to leave myself some space because I need to get each of these fractions to have my common denominator. So my goal is that this first denominator becomes 24x squared and this second denominator becomes 24x squared. Because then they'll have a common denominator. We said that's going to be my lowest common denominator. So what am I going to have to multiply 6x by to get it to 24x squared? 6x times what gets me 24x squared? Adam. 4x. And we use that 4x just because we have to get the denominator 24x squared. Now, back to basic math. When I multiply the denominator by 4x, what do I have to do to the numerator? Multiply it by 4x. This right here in blue is, I abbreviate it FOO, a form of 1. Whenever we're working with expressions, you always have to multiply by a form of 1. So whatever we need to do to the denominator to get our common denominator, multiply the numerator by that same quantity. So we have 28x. And then 8x squared times what gives me 24x squared? 3. And if I'm going to multiply the denominator, so it's got my common denominator, to keep this equivalent, numerator gets multiplied by 3. This whole fraction is called a form of 1. 3 over 3. 4x over 4x. Form of 1. Numerator and denominator are the same. So my numerator then is 9 times 3, which is 27. So that's our new steps. Hang on. So my common denominator has x squared in it. This denominator started out with only an x. So to get it to x squared, I need to multiply it by another x. Whereas this one is already set with x squared. So those are our new steps. We're not done this problem yet. And I will tell you, these are some of the longest problems in this class. But this just gets us to, this is what we had on Wednesday. Oops. This right here is what we had on Wednesday. We have a common denominator. What part of the fractions do we add? When you're adding fractions, what do you add? Top, the numerators. So this is where we made one fraction now. This is what we did on Wednesday. So we take 28x plus 27 over my common denominator. Dennis. Yep. So my given denominator is 6x, but my common denominator is 24x squared. So I'm looking at what do I multiply 6x by so I get 24x squared. So 6 times 4 will get me to 24. And x times x gets me my x squared. So what I'm doing is I'm focusing on the denominator. I'm saying 6x times what gets me up to my common denominator. And then whatever we do to the bottom of the fraction, we've got to multiply the numerator by the same thing. And so over here, I was given 8x squared. I say 8x squared times what gets me to 24x squared. Again, we're focusing down here. So 8x squared, well, I've already got the x squared, so I'm going to need just the number. And 8 times 3 gets me to 24. So after I've got my common denominator, we're back to Wednesday. I'm going to make one fraction, combining my numerators. Now, can I simplify? Can I combine this numerator any further? 28x plus 27. No. They're not like terms. What's the last thing I want to look for in one of these problems? Last thing I'm going to try doing this problem. Simplify. Now, if I'm going to simplify, what do I have to be able to do? Begins with an F. I'm going to simplify factor. So, can I factor 28x plus 27? Is there any GCF for 28 and 27? No. That's how you know you can't simplify. When you can't factor anything, you can't simplify. Even if you use a different method for simplifying, something has to be factorable. And this one we can't simplify any further. So the real work in this particular problem was just getting to that common denominator so we could write it as one fraction. Sometimes you've got to go further than that. But if you can't factor your answer, you cannot simplify it. If you can't factor it, you can't simplify it. Questions? All right, B. 1 over x plus 5 plus 6 over x minus 2. Most common mistake that I will see on your test is that people will just try to add these right now. What do you have to add and subtract fractions? Same denominator, common denominator. So first thing we want to do is find what is our common denominator. So I have binomials. Neither of them can be factored, which means I'm going to put them in parentheses. So it's all or nothing. So my first factor is x plus 5. How many times do I need that in my common denominator? Once. I've only got it in my fractions once. And then what else goes in my common denominator? X minus 2. And again, right next to each other, nothing in between them. X plus 5 times x minus 2. So what we're going to do now is we're going to take our original problem and leave some space, because we need to get each fraction to have a denominator with both an x plus 5 and an x minus 2. And neither of them does to start out. So what I'm looking for now is something to multiply each of those by so they get both factors in their denominator. So if I look at this first fraction, it's got x plus 5. Which factor of my common denominator isn't missing? It's got x plus 5. X plus 5 is right there. It's missing the x minus 2. So I'm going to need to multiply the denominator by x minus 2, so it's got both the x plus 5 and the x minus 2. But whatever I do to the denominator, same thing has to happen to the numerator. This has to come in as a form of 1. For my second fraction, so my second fraction right now is 6 over x minus 2. I need this denominator to have both of these factors. What's going to go into my form of 1? Which factor is missing? X plus 5. So I've got the x minus 2. I need the x plus 5, so that's what goes into my form of 1. So I look at what I have in my denominator, and then I see which factor's missing from my common denominator. I looked at what I had, and I figured out what was missing. What's missing goes into your form of 1. What do you think is going to happen in the numerators this time? Distribute. So this looks like the problem I gave you in your warm-up today, where, and if you need to, I mean, you can bump those fractions right up over to each other. This is still one fraction that I'm trying to simplify. This is one fraction. Just like we did in warm-up, you're going to distribute. Well, when I distribute 1, that one's not too exciting. I get x minus 2. What am I going to distribute in the second fraction? 6. So I'm going to have plus 6x plus 30. Questions up to this point? Where we got those forms of 1 from, why we're distributing. We're not done yet, but just up to this point. Chris?
So you just bring them down and then take them and then you do the form of 1 for the opposite?
Mm-hmm. And it's not always the opposite, because you might have more factors. It's just the missing one. Whatever it's missing from here, multiply both the numerator and denominator by that. Okay. And then because it's a monomial times a binomial, we've got to distribute. And we can write them over our common denominator since they both have factors x plus 5 and x minus 2. So we don't need 2 fractions anymore. We can get down to that 1 fraction. What do I want to do next? This is just like Wednesday. Combine them. Combine in the numerator. So we made our one fraction. This is what we did on Wednesday. One fraction. Step 2 was we needed to combine the numerator. So I have x plus 6x is 7x. Negative 2 plus 30 is 28 over, and always leave those denominators factored. There's never a time you will want to FOIL that back out. So one fraction, then combine. And what was the third thing we looked for on Wednesday? Simplify. So can I factor my numerator at all? Yes, DeAndre, what do you got? 7 and then an x plus 4, so it had a GCF. Now the nice thing about these problems is your denominator will always be factored for you at this point. So I factored my numerator. Can I cancel anything? Do I have the same factor in the numerator and denominator? No. Bummer. Oh well. That's it. That happens a lot with these longer problems. You get down to the bottom, you factor it, you're good, you're ready to cancel, and then nothing does. It happens. It's very hard to make one of these problems that where you get down to this point and you can cancel it. So if you had left this answer on this particular problem, you would receive full credit, but you never know. You never know if it will cancel, so you just go that extra step, factor that. Questions on this one? We're ready to see another. All right, C. This one's subtraction. First thing I need when I'm adding subtracting is a common denominator, LCD. And we're only going to get that from factors. So I'm going to start by factoring my denominators. So the first denominator factors, difference of two perfect squares, x plus 2, x minus 2. So I'm not going to use the x squared minus 4 anymore. How about x squared plus 4x plus 4? X plus 2, x plus 2. No longer going to use this. So my first factor in my LCD is x plus 2. How many times do I need to include x plus 2? Once, twice? Twice? So how many times do I have x plus 2 in my first fraction? Once. How many times in the second fraction? Which of those is bigger? Got to have it twice. Always the most here. And the other factor I need, x minus 2. And that will cover both of my fractions. So I'm going to bring down my first fraction. But it's missing a factor from my LCD. I need to get one more factor into that denominator. What's it missing? It's missing an x plus 2. It's got one x plus 2, but I'm saying I need two of them. So I'm going to put into a form of 1 my x plus 2s. Minus. Now, what I would recommend if you have a subtraction problem, just the easiest way, what's going to look like the least work for you, is to put the minus with the 3. Put the minus with the 3. Because when you distribute a negative 3, you take care of both the negative sign and the 3 all in one step. As opposed to distributing the 3, going back, distributing the negative. You can do that all at once. So right now, the second fraction has x plus 2, x plus 2. What factor am I missing from my LCD that needs to go into my form of 1? X minus 2. And now it's a little more spaced out, but it looks exactly like our problems from Wednesday. I can see now that both of the denominators have the same factors, so we're back to just looking at the numerators. So what am I going to do to start simplifying these numerators? Distribute. Same thing as in the last problem. Distribute. So I'm going to start by distributing the 5. So I have 5x plus 10. And what number am I going to distribute in that second fraction? Negative 3. I would distribute it as a negative. So you take care of both the negative and the 3 all in one step. So I have negative 3x plus 6. And if you think it looks funny with the fractions not having anything between them, you can always put an extra plus in there. Plus and negative is the same as subtracting. And what's my, that got really scribbled out. What is my denominator now? X plus 2. It doesn't matter what order you put it in. X plus 2, x minus 2. It's my LCD now. This right here is my LCD now. We're still working on the numerators. Got to get those like terms together. So I'm looking at 2x plus 16 over x plus 2, x plus 2, x minus 2. So this was our one fraction step. This was our combined step. And what's the last step? Simplify. Can I factor my numerator? Yes. I can factor out a 2. Does anything cancel? No. And on your final answer, you may write x plus 2 squared if you want to save yourself a little bit of writing. So I was able to factor it, but still did not simplify. Questions? We're at least going to start this last one. The one that we're not getting to, E, is fine. It's only on there as an extra example if we have time, which we don't, which is fine. So D, first thing we need is our LCD. So I'm going to get us our factors just since we're getting short on time. X plus 7, x plus 5, and x plus 4, x plus 5. So what is our what's going into our LCD? I need x plus 7. How many x plus 5s do I need? That's the one we really have to think about. 1. It's only in each fraction once. And then I need my x plus 4. So if I look at my first fraction, and I see what it has in its denominator, what needs to go into my form of 1? X plus 4, the factor it's missing. I'm going to bump the negative over with the x. Makes it easier to distribute. If you want, put plus in between. What factor do I need in my form of 1 with this last fraction? X plus 7. Now we're back to the same step of multiply the numerators, which is just distributing. So I have 2x squared plus 8x. Distribute it as a negative x. Just save yourself some work. Negative x squared minus 7x. And now you can just write that denominator once. The order of your denominator does not matter. Combine your numerator. Gives us 1x squared plus x. And am I able to factor the numerator at all? Can I factor my numerator at all? X squared plus x? What do they have in common? X. Does it get me anywhere? No. Oh well. We had to try. One of these days it'll work and we'll be able to cancel something, but Not today.